Assalamualaikum to Encik Muhammad Asri bin Azizul. We are from group number 3 and we are from Faculty of Engineering Technology. Before that, let me introduce my name. My name is Putri Mulyana binti Yazid and this is my group members, which is number 1 is Muhammad Ahiruddin bin Sarifuddin, number 2 Muhammad Akil bin Ramlan, and 3 Muhammad Nasran bin Nasharuddin. And that's all for me.
So basically, the coefficient of restitution is a measure of how much energy is lost in a real collision. Specifically, it is the ratio of the speed of separation after a collision to the speed of approach before a collision, which is E equal to V after divided by V before. As you can see in the screen, the problem statements of the research are how to investigate the coefficient of restitution of the objects. The second one is how to solve the solution of the question given. And the last one is how to use the equation correctly. Our objective of the research is to demonstrate work effectively and cooperate in group to complete the project task. The second one is to discuss about the coefficient of restitution, and the third one is to show the solution and calculation of the projects. Now I want to share a little bit about impact. So impact occurs when two bodies collide during a very short time period, causing large impulsive forces to be exerted between the bodies. Common example of impact are a hammer striking a nail or a bat striking a ball. The line of impact is a line through the mass center of the colliding particles. In general, there are two types of impact, which is oblique impact and also central impact. So oblique impact occurs when the direction of motion of one or both of the particles is at an angle to the line of impact. Central impact occurs when the directions of motion of the two colliding particles are along the line of impact. So next I will give to the next presenter. Thank you.
Hello, my name is Muhammad Ahiruddin Safudin and I want to talk about our group question. The coefficient of dissociation E VB2 minus VA2 VA1 minus VB1 on a smooth horizontal surface. Investigate the coefficient of distortion for this six object in this three scenario. The number one is student A. Object A collide with object B, then object B collide with object A. Student B, object C collide with object D, then object D collide with object C. Student C is object E collide with object F, then object F collide with object E. About our question, we know about the coefficient of dissociation. E is a measure on how much the energy lost in a real collision. Specifically, it is the ratio of the speed of of a separation after a collision to the speed of approach before it collision. For a collision with a perfect conservation of mechanical energy, E equal to 1, the coefficient of dissociation is a convention way of specifying how much energy in a collision is transferred to internal energy. In general, it will depend on the specific material which are colliding, but under experimentally realizing the condition, it is a constant factor representing the energy transfer from kinetic energy to internal energy. Okay, about this set of element, the constant element is initial constant velocity, the changes element is impact of object, and the observation element is coefficient of distortion. Thank you.
Assalamualaikum, I know my name is Muhammad Akib Ramlan. I will explain to you guys about our group demonstration. Okay, and first, our group experiment will divide it in three scenarios. First scenario is direct center impact, and the second scenario we will cover the impact of oblique center impact, and the third scenario we will cover the surface impact. Okay, we continue to the first experiment scenario, that is direct central impact. Okay, first, direct central impact is the velocity of two particles direct along the line of impact. Okay, we go to our first scenario. Okay, as you can see, and this is our experiment. We just use the two ping pong ball, and we just take the place, and this is the first before it's collide. Okay, as you can see now, this is our setup before the experiment start, and we had measured the distance between the ball and the plane of contact, and we just make sure the distance between the ball and the plane of contact is the same with the another ball with the plane of contact. Okay, now you can see this is our experiment in the first scenario after the collide, and you can see the distance between the ball and the plane of contact, and now we must to measure the distance between the plane of contact and the ball, and the measurement what we get, we must to take note into our notes because we want to do a calculation later. Okay, that is our result in the first scenario, that is student A, student B, and student C. And for the result for scenario 1. Now we continue to the second scenario, that is oblique central impact. Okay, oblique central impact is the velocity of two particles are directly along the line other than the line of impact, and you can see that is the simple way or the theory how we want to do this experiment. You can see the diagram below the definition of oblique central impact. Okay, this is our setup for the second scenario. We just put the two ball in a same place, and we just target the ping pong will collide at the plane of impact that we put the just 40 cm. For the second scenario, we had to do the same things like the first scenario, but at this scenario we had to central oblique impact. We had take the angle of ball collide is 30 degree. We also had put the ball in the same distance, that is 40 cm. We also make sure the collide of the both ball is 4 seconds because we want to make sure the initial velocity is same. After the collide, we have take the distance between the plane and the conduct, and the distance after the collide we have to measure because it used for us to do the calculation after this. Okay, this is our group result for the second scenario for student A, student B, and student C. And now we go to the third and the last scenario of our group experiment project. Okay, the last is surface impact. The definition of surface impact is velocity of one particle with stationary particle. Okay, this is our group setup for the third scenario. We just put the ball in the impact. So as we know, the impact of this scenario, the impact will collide with the things that not move. So we had stay the ping pong ball not move. So the velocity of the another one ball is 0, and the first is moved. So the first one ball will collide to the 0 velocity ball. Now this is our result, our picture of the after the collide happened, and the distance between the ball with 0 velocity and the first ball who is collide the 0 velocity ball, and we take the measurement between the first ball who not move and the second ball, the distance have measured, and we calculate, we measure and put it in our table to calculate later. Okay, this is the result of the third scenario of this experiment, and this is also the same thing with student A, student B, and student C. Okay, now we go to the last section, that is discussion. Okay, the measure data may be very thus. We decide to calculate the average by conducting the experiment 3 times, because in this experiment we have analyzed, we have 4 limitations. First is air resistance. Then our precaution is switch off fan when do experiment. Make sure all the window and the door is closed. And the second limitation is parallax error. And our precaution is making the mark on the point accurately. Eyes must perpendicular with the tape or measuring tool. Third, student use the different measuring tools when measure the measuring part. Make sure all the student or our group member use the same tools when do the experiment. The fourth is design of our experiment or how we conduct the experiment. Is limitation method, and we have the limitation of our instrument. And our precaution is because our group in this pandemic we have to do in our home, and our precaution is do at lab where all the instrument is complete. And that's all from our group. Thank you.